Yes. Okay, then this photochemical smog is looking like it is very common term, but really it is not like that. As I told you in the previous class, how dangerous is. There are different types of smog we have. For sulfurous smog, we have discussed that contains lot of sulfuric acid as well as sulfurous compound are there. Because of that, what is the source for sulfurous compound or sulfuric acid? You might be knowing that. How it affected, where it is affected, what are the history of that sulfurous smog, you know. Then we have seen a photochemical smog. How it is formed, I have explained. What are the components supposed to be involved in that? I have explained. Then photochemical smog, where it affected more, how it was affected, how it is in the developing countries and developed countries. Then how was in Delhi, in Indonesia, and what are the reason for that Indonesia smog issue, how it was affected, where it was affected, everything we have seen. Then we are going to see now ozone and photochemical smog. Both are so ozone and photochemical smog. These are only example of what? Okay, anyone of you could answer to me? Photochemical smog and ozone are all example of. These are all example of what? These are all primary pollutant or secondary pollutant. If I am alone speaking, I am getting bored. Some of you also should open the mouth. Na? Janaki and Kumari Tandra, Odapalli, Loka Pavani, Raki ma'am. Okay, you please tell me, this is very important. Casually, whatever the question I am telling, those are all very important and subject knowledge point of view. Wherever it is exam point of view is important, I myself tell. Now I am telling you, I am asking you all what this ozone and photochemicals marks are an example of what? Or I can say in another way, these are all primary pollutant or secondary pollutant. Primary pollutant, secondary pollutant, it is one of the important questions that also will come repeatedly. That came many times, it comes. So ozone and photochemical marks are an example of secondary pollutant. Because ozone is not forming directly, photochemical smog also is not forming directly, but both are formed by the photochemical reaction only. So what are the components essential for ozone? Oxide of nitrogen must be there. It undergoes the photolization. Then it releases from oxide of nitrogen into oxygen molecule. That react with oxygen with a lot of energy or sunlight. It makes ozone. That is the basic reaction. How photochemical smog is formed? Photochemical smog means it is a kind of mixture of chemical. We can't say this is only the product is coming out. When the sunlight, oxides of nitrogen and hydrocarbon, all the three comes close together in the presence of sunlight, some sort of in the form of ultraviolet radiation. And many reaction is taking, complex reaction is taking place in the atmosphere, which produces many compounds, including acid rain, rains also, even smog, ozone, along with that many chemical compound. At the end of the reaction, we could understand that this is a complex product, mixture of product form. Many are highly active and more dangerous. So the major problem in for this photochemical smog in many cities only, where vehicle pollutions are more. Vehicle pollutions are more means we can say it includes the particulate matter and whatever the things are emitting from the oxides of nitrogen emitting. hydrocarbon must be there. Then whenever the plenty of sunlight is, this reaction is going on, then it forms the photochemical smog. But beyond that, the formation of ozone and photochemical reaction, formation of photochemical smog, which depends on many factors. We can't say the concentration of these only. The location and climatic condition, these are all important. Already I told you how that when I have defined what is meant by smog, that time I would have told you people. Smog means it is a mixture of smoke plus fog. But whenever the emission is there, sulfurous emission or sulfuric acid forming compound or acid forming compound, whatever it may be, whenever it is there, immediately it dispersed from the air, nothing will happen. Then there will not be any sort of issue. It will be there when the concentration is keep on increasing. And before deposition, it will, when it moves from here and there, it converts from one form to another form. When it goes up like that, then it causes a problem. But sometimes, if it is dispersed immediately, the effect of photochemical smog is very less. Because whenever we are facing that, preventing when the emission is there from the source, which is prevented by the dispersion by stable mass or sink mass, that time if bright sunlight is there, when hydrocarbon, oxide of nitrogen, everything comes close to the together, then which undergo the photochemical reaction, which forms many things I told you. One among them is ozone and another one is hydrocarbon products. That is photochemical smog, including all sort of acids, particulate matter. Even when that vehicular emission is there, some heavy metals also are releasing to the atmosphere like lead. So those things, when it accumulates in the stagnant mass, or into the stable mass, then the emission is keep on increasing. The air cannot move from that place to anywhere due to that stagnation. Then there will be a huge problem. We can't even imagine that what it happened. That's what under that condition, how many places, how it was affected, we have discussed last time. Here also, the photochemical smog, which is nothing but, it is a kind of mixture of chemical which is not stable, which are highly, these are all unsaturated compound and a highly reactive compound. Once the reaction is started, means non-endingly the reaction is keep on going and it keep on producing one or other product. First product react and give a second one, and the second one react and give the third one. Again, the third one also turn into react and give the fourth one. Like that, it is going on. Where it stop, where it start, even we can't find out. Like that, it goes on all the directions. So the reaction endlessly going on. Then we can imagine then how much it could be accumulated in the atmosphere. These are all looking like a joke, and we are telling like that it is something like a hypothesis. No, these are all the things practically really happened. That's what those many people, 2 lakhs people, 20 lakhs people and all, it is not less. First of all, a disposal of dead body itself big issue. Everybody died, then who will dispose? 2 lakhs, 20 lakhs people died means in one particular city or one particular place, then who will do that other things? Everyone is in problem. So we can't talk about what could be the reason. Okay, such a product only, but where it forms, how it forms, that we should know since we people are doing the PG course. Photochemical smog is not only Indian product, it's a worldwide issue. Wherever the cities are lying in a low altitude condition with a high population rate and the industrialization also, it is dense. When the condition is like that, the tropospheric ozone is produced and that will be formed and also which is spread out in the manner of low level clouds. So like Delhi and Bombay, those are all, we know that low-lying area, their latitude is very less. And when that condition, the pressure is less. If the pressure is less, means obviously temperature is less. If pressure temperature both are less, means volume must be more. Then high volume things cannot move from one place to another place. So that is looking like a sinking mass. So what is happening there? Then the air cannot move, means the air became stagnant. If it is stagnant, means whatever the sources are releasing that pollutant cannot be dispersed, it will be accumulated there only for quite a long time. When it happened like that, then whatever the compound we have discussed about the secondary pollutant, those are all things started for. Among everything, ozone is the one of the important component of ozone. Let me show the slide now. I am talking for me, or I am talking with you all, I don't know. Ozone is one of the important or major component of photochemical smog. This ozone is something like a brownish gas in the atmosphere that covers many urban areas during the hot, sunny days of the summer. We know that how this ozone is produced. This is produced by the chemical reaction between hydrocarbon, nitrogen oxide in the presence of strong sunlight or bright sunlight. The product of them is whatever the reaction which is taking place under the sunlight is called photochemical reaction, and the product which comes out of photochemical reaction in atmosphere with the air pollutant is called photochemical smog. And these photochemical smog are higher intensity wherever the intensity of sunlight is more, and warmer the day, the larger the amount of ozone is produced in any places. Since automobiles mainly generate hydrocarbons and the oxides of nitrogen, but ozone level gradually rise in the morning and is a peak in the afternoon, and it was a peak in the late afternoon and also up to the 4 p.m. And cloudy days, the ocean production is reduced. After sunset, everything will be totally declined. This is the formation of photochemical smog. But what will happen sometime? It stops altogether after the 4 p.m. or after the sunset. But in photochemical smog, in addition to the ozone, peroxyl nitrate is also formed. But what the difference is there between ozone and peroxyl acetyl nitrate? Ozone is an oxidative reaction product, so which initiate and carry over the oxidation reaction. But peroxyl acetate, it is something like again it is unsaturated compound, which is also excellent oxidizing agent, and they readily react with any product because that is unsaturated compound, and including those found in the living things, like causing destructive changes. Ozone, we know by the name itself, we understood that peroxyl acetate nitrate, but the person who is having the subject knowledge about that only can find out. Otherwise, we feel that that is one of the product which must be having many applications. So what we are studying, no, that is not the case. The case about the pan is it is highly oxidative, which affect the sensitive part of our body like intestine. I am only speaking, none of you are speaking. Are you there or not? Hello? 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 Yes. Ma'am, can you hear me? Ma'am, can you hear? Yes, ma'am. Okay, then fine. Okay. Now, condition for photochemicals. What are the condition essential for this photochemical reaction taken place in the atmosphere? There are three important conditions there must be there in the atmosphere. Whenever these three conditions are there, the photochemical smog must be formed. In that, there is no doubt at all. It is formed by, in the presence of, the air must be stagnant, and also there must be bright sunlight, and a high concentration of hydrocarbon and nitrogen oxide must be there in the atmosphere. That time, and this photochemical reaction is started at the below, actually lower atmosphere means wherever that atmosphere level is, the place is, latitude is less, or we can say from the sea level the height is less, like that kind of area. They are called lower atmosphere. By the interaction of hydrocarbon and nitrogen oxide, which releases the exhaust of automobile, that we know that they are all mobile sources. So from the mobile sources as well as some stationary sources, both combinedly, which releases these carbon oxides of nitrogen and hydrocarbon too much. When these two mixtures are in particular proportion with the bright sunlight, the photochemical reaction are taking place. And air must be stagnant. That word, if you are not writing, means that is not the definition for smog, photochemical smog. The air must be stable. The stagnation is very, very important. And also which covers the interaction between results the series of complex reaction that is called a chain reaction, which produces a secondary different types of secondary pollutant. I told you all already: aldehydes, ketone, peroxides, peroxyl nitrogen, peroxide components, and organic peroxides, and peroxyacetyl nitrate. Many compounds are there formed. Now I am asking you people, you just to open your book. There must be one diagram on the page number. Let me check and tell you. That is on the page number below this ozone and photochemical smog. Actually, I cannot load this figure in my system now. You people, please open that page where the photochemical smog is there. Have you opened page number 36 or 36? Yes, 36. One diagram is there. You please look at that. That is the pathways of all the photochemical reaction. How it is showing? The sunlight is falling on something. What is there? Any one of you can read out that? No one is there. How they can read? What will happen? Generally, I will explain. When the sunlight is falling in the presence of hydrocarbon and oxides of nitrogen and nitric acid, then that will be the photon is converting that NO2 into NO2 is there in the atmosphere, and hydrocarbon also is there in the atmosphere. Both are from, most of them from the automobile sector. Then that NO2, by absorbing solar radiation at the nanometer of 420 nanometer, that will be break up into NO into NO. That means the radiation which comes out of that particular wavelength only, which produce this reaction of NO2 is being converted into NO plus O. Here it absorbs the energy at the wavelength of 420 nanometer. After that, what will happen? This absorbed the broken NO2 into NO plus O, the NO go and react with oxygen that produces NO2, but the O react with oxygen, and which produces ozone, and that ozone which produce not only ozone, along with that some of the hydrocarbon also will released. Then and this first of all, what is happening? NO2 is broken down into NO plus O. That O is react with the atmospheric oxygen molecule O2. So we know the formula of ozone, that is O3. That means one atomic form of oxygen combined with one molecular form of oxygen, that is O2. O2 combined with O, which gives O3. This is only the reaction is taking place for formation of ozone. Here the critical point is, if we study the formation of atomic oxygen, the formation of ozone at the lower atmosphere level will be reduced. That is in our hand only, isn't it? And that oxygen which releases the oxide ozone along with some of the hydrocarbon free radicals. Then that hydrocarbon material which undergoes for decomposition, that that hydrocarbon react with that saturated and unsaturated hydrocarbon, that ozone react, and which releases into the atmosphere in the form of ozone directly, and react with the hydrocarbon that also releases into the atmosphere directly. And this ozone, whatever the ozone and the hydrocarbon is there in atmosphere, this again react with that hydrocarbon and other living things, decomposition reaction, whatever it may be there in the Earth surface, which releases NO2. And the major component for formation of this particular reaction for ozone and other photocarbon, specifically ozone we can say, and also hydrocarbon. The NOx is formed, as I told you already, around 600 or above 600 degrees centigrade only. That means combustion of fossil fuel, combustion of petrol or petroleum taking place in the engine, that there only. And hydrocarbon also released most of the hydrocarbon during the reaction, before the reaction, after the reaction, transportation, filling of the tank, filling of vehicle tank, whatever it is, there lot of are huge emission rates, vaporization of this hydrocarbon will be existing. One form is when the combustion of fossil fuel also releases NOx and hydrocarbon. And unburned hydrocarbon, combustion of fossil fuels releases huge quantity. And some of the unburned hydrocarbon, which are all released in the form of vapor into the atmosphere, because those are all highly volatile compound. And all these things undergo many reaction. At last, it produces ozone through the reaction of photochemical. So here the major compound is, you can look at your figure and see that the major emittent of NOx is automobile industry, and a hydrocarbon also, which contribute too much in different ways, like evaporate different series as in the form of volatilized hydrocarbon. These two are emitted from the vehicular only. So vehicles are the culprit to release a lot of NO2 and hydrocarbon. When these two chemicals combinedly react with other chemicals or in the presence of sunlight, which undergoes many chain reaction, at last which produces photochemical smog or ozone and everything. Now, if you remove the vehicle from that figure, you just look at that figure, which is on the page number 36, I think so. You just remove the car from that figure. How this atmosphere will get plenty of NO2 and plenty of hydrocarbon, it is not at all possible. Are you agree with me? Are you agree with me? Okay. Then what will happen if you remove that vehicle? There will not be any emission of NO, there will not be any emission of hydrocarbon. Then there will not be any cycle is formed to produce the ozone, and the produced ozone is accumulated in the atmosphere. That also will not happen. So the main culprit is us only. Through us, the vehicle is used. Then only the vehicle released to the atmosphere. If we are not using the vehicle, there will not be any ozone formation. That's what you can understand from this figure. Nothing else. It is very, very important. In many questions, many times they have asked what is ozone and how the ozone is formed. I write about the ozone and also photochemical smog. These two combinedly very important question. Now you look at that, how this photochemical reaction is, now how the ozone is formed, we have explained through the diagram. Now, photochemical reaction, how it accumulates the hydrocarbon, we'll see. Actually, we know that according to our latitude longitude condition of India, the prevailing winds are flows from the west. That's what we are having two monsoon, northeast and south. So the wind is flowing through from the west, and because of what will happen, there are, we can say, according to the industrial laws, according to the vehicular emission or domestic burning or commercial burning, many processes are going on the world. Some of the reason the air or the pollutant are released at very high temperature. In some of the reason, that depends upon the process, what is involved, where it is emitted. From the power plant means obviously it will be at very high temperature. From the vehicle means obviously it is from very high temperature. But somewhere some of the process we are doing small things, and sometime we could see that there will be a emission of decomposition emission from the decomposition, and some of the anaerobic process, through many process, this hydrocarbon releases are there in the atmosphere. Even nitrification, denitrification process also contribute a considerable quantity of NO2 into the atmosphere. So like that, many things are there. But even then, so because of that, the atmosphere is being warm in some area, and it is very cool in some of the area. And when the wind flows from the west, what it will happen? The cool air, whatever the cool air is there, that is entered into the valley of the mountain. And when the cool air enter into the mountain or valley, whatever the warm air is there in the same region, which is accumulated at that place previously, those gas warm air as little move up, because cold air is flowing means what are the hot things are there, that density will be less, so then less dense things will be move up. So below that hot, I am telling very interesting and important thing, listen me very carefully. And because of movement of cold air, the hot air rises up, and again the cold air is coming into the valley, because it's keep on increasing the release. And the hot air layer, which is being sandwiched in between the two layers of cold air. Okay, so the two layers of cold air, which behaves or act like a lid on the valley. So the lid, what will happen if you open, will open, it close, it moves up and down if it is automatic. In such a this kind of situation, when the warm air is sandwiched between the two cold air, then the cold air act like a lid, or the concept of this combination act like a lid in the valley. And this condition is called the thermal inversion. But what happened? We know that in the air is trapped in the valley. We know that because that is covered by the ring of mountain. So whatever the air entered there it will be cooled down, and once it's cooled down means the density will be increased. Then the density will be increased means we know that pressure, temperature, how it could be. So it is trapped in the valley. Then sometime what will happen in such a thing? Whatever the warm air there in the same region, which further increase the concentration, and it covers by a many layer of cold air. And again, when the density increases, it is pushing down only, instead of it is pulling out. It is pushing down only on the same area. And it occurs continuously. So the warm air and the cold air it cannot move out of the area, because there is a ring of mountains. There will not be any movement of air flow will be less. That means wind is less. And without normal air circulation, and every day the concentration is increasing, the smog accumulates in that particular area. and the harmful products are continuously formed, and also its concentration is keep on increasing until a major weather changes are coming into that area. And very major changes means what? The temperature of that cold air sandwich part is supposed to be increased, or any storm has to come, or any totally different climatic condition or weather condition has to come, or summer has to come. Any one of that is very big change will come in that area. Whatever the sandwich or lid we have spoken, that will not move from that place. It will be accumulated in that place for quite a long time. And even then, this photochemical reaction is keep on undergoing, and which has very nicely they have given in your book. This photochemical smog episode is something like everyday daily rhythm, distinctive daily rhythm will be there, because one day temperature this much, that much, next day temperature must be there, then concentration of this product will increase, next product will be decrease. But whatever it may be, every day some reaction is going on, and it is keep on accumulating in that particular area for quite a long time. When this reaction is happening in the absence of wind around the same area, then the movement of air must not be there, including the pollutant. But anyhow, whatever it may be, it is happening in the mountain. But in the urban or rural area, whatever their regular activities, traveling, industrial process, cooking, transportation, all those things are keep on going on. So when that regular activity is going on, but in the early morning, the concentration of CO, NO, and hydrocarbons are less, comparatively less. Don't say that it is not. When the traffic is started increasing, this emission is also started increases, and slowly, according to the traffic condition, it started build up in the atmosphere. Then what will happen? The amount of then NO only it's releasing. The NO is being converted in the NO2 in the presence of sunlight and also oxygen in the atmosphere. And NO2 then from the NO it starts forming NO2. When the NO is after forming of all the NO2, that used to happen after 1.5 hours at peak reached that NO destruction or disappearance, then only it is completely converted into NO2. Then it is followed by the formation of other photochemical pollutant in the atmosphere. They are the photochemical other pollutants are aldehyde, ketone, and this acetyl nitrate, peroxide, all those things. But they have given an example in your book with that aldehyde. Then once this NO is disappeared and NO is completely converted into NO2, then only it started appears aldehyde and followed by ozone in the atmosphere. And this reaction is continued by disappearance of NO, so that the concentration of ozone are higher shortly afternoon, and just after the aldehyde peak is reached. After starting form of aldehyde only, ozone form. When it reaches the maximum shortly at the afternoon and up to 4 p.m. we can say, when it started appears, when that aldehyde peak, after reaching the aldehyde peak, then only this O3 started forming in the atmosphere. Then this allows to form most of the ozone from the atmosphere. After disappearance of aldehyde, what does it mean? Already the NO is converted into NO2. And when the NO2 reaches maximum, that time there will not be any NO. When it reaches, started disappearing this NO, the formaldehyde started appearance and followed by ozone. And this reaction is taking place. The formation of ozone buildup in atmosphere is taking place just to reach the aldehyde peak over. Because when all the reaction is going on, the reaction rate is slowly goes up and it goes down. How it is being correlated with the sunlight? After peak traffic, after in the morning, when started getting that bright sunlight, the traffic is keep on increasing. It reaches the maximum at the afternoon and it started falling till in the evening or sunset. According to the same rhythm, the ozone formation is also occurred. In the morning, the photochemical reaction started. Again, I will explain. NO is being converted into NO2. After 1.5 hours of peak reached NO, then the NO2 is completely formed. And after NO2 peak reached, then the next reaction followed up, and which forms formaldehyde. After reach out this formaldehyde peak, ozone started appearance. When the ozone is started appearance, that rhythm is going on. Right from morning to afternoon, the concentration of ozone is increased up to 4 o'clock, but it was high shortly afternoon. And then after it started reducing when the sunset. When it happens, the ozone peak reaches, when it reaches after the peak of aldehyde has passed away, then only ozone started appears. Then this allows other free radical chain reaction also in the atmosphere to form the peroxyacetyl nitrate and other form of irritant or ketones, many things in the atmosphere. As a rough approximation, one molecule of peroxyacetyl nitrate, that is called a PAN, one molecule of peroxyacetyl, which produces every 50 ozone molecules. And you can understand the calculation. Every molecule of or one molecular PAN is produced for every 50 ozone molecules. So this is peroxyacetyl is formed, okay, that is irritant, that is different. The concentration is balancing in such a way 1:50. But when it reaches the late afternoon, when the return traffic must be there, the people when they are going to office, the traffic must be good. And that late evening after 4, 5, 6 and all, the return journey must be there. Then the return traffic is there, which also releases NO and that can be converted into NO2 and which is formed that further ozone and other aldehydes, everything. But what will happen? If it is the case, the level of nitrogen oxide do not follow the distinct highly daily pattern, because today we are reporting that this much oxide of nitrogen. The same thing may not be coincide with the tomorrow's emission. The reason behind why it is being like that, we do not know how the wind could be. What is the speed of wind and what direction the wind is, we cannot understand. And another thing is how the cloud cover condition. What is meant by cloud cover condition? What could be the meaning of cloud cover condition? Any one of you? I alone speak now, I am getting bored. Any one of you speak, it will be good. What is meant by cloud cover condition? I'll give 1 or 2 minutes time, you people can, because I said the emission of NO, it is not only depending upon the traffic level. May I know who is only anyone is sending any messages? Ma'am, any messages are coming? No, na? Okay. So what I am trying to say here, I told you while in the, okay ma'am, no problem. While the return traffic will be there must be NO and NO2 for conversion. Then ozone formation must be there. Then we can count this much could be the ozone formation in a particular area, like that we can do. But we cannot say the level of NOx in a particular pattern. So every day it is the same pattern, we can calculate like that, but it is not. What are the factor reason behind that is? And then whatever the NO and NOx is formed, which depending upon the many things I told, many parameters, that is one of the important parameter is The nitrogen oxide, when it releases into the atmosphere, whether it is in stagnant air or it is dispersed in the air. Even if it is dispersed in the air also, the reaction will be taken place. But sometimes the ozone formation may not be there because the air is not stagnant, means the interaction or the photons which absorb for that reaction will be varied. If they didn't absorb enough photon, then the breakup won't be there from NO2 to NO and O or NO to NO2 conversion. From that only the sequence of reaction will undergo to form the ozone. We'll see further how the ozone is formed and how the ozone is disappearance in the atmosphere also we'll see. The reason why we cannot compare the morning traffic and return traffic in the morning, there must be a meteorological parameter variation. In the morning, the sunlight is, the intensity of sunlight is keep on increasing from morning to peak afternoon. Up to 2 o'clock, 3 o'clock, 4 o'clock also the same intensity we could observe, you can feel in Hyderabad specifically. Then after sunset, it slowly reduces the photochemical reaction, it stops. That will be known parameter, but they are telling that something else is being interpreted, involved in that reaction, which distract the formation of ozone. What are they? One is wind. Wind means we cannot say only flow, air movement. The wind direction and wind velocity specifically it's very important. So those things, and also cloud cover. Cloud cover condition means what? What are the essential parameter for forming the ozone? If you know, then now you could answer what is meant by cloud cover condition. Cloud cover condition means what? So how it plays on the formation of ozone and how it plays roles on the NO2 NO2 conversion, and also subsequently it makes the ozone. How it could be correlated, how it is related to the ozone formation. Can you, I will give you 2-3 minutes time. You please tell me and also convey to me. You no need to tell. If anyone of you ready to explain, I will well and good. Or you can send the message also, no problem. If you know the conditions for ozone or photochemical smart, now you can answer to this answer. I said how the wind is affected. That is, I told you that is the speed of the wind as well as direction of wind. That is keep on changing. So that could be the reason, because now one direction the chimney will be there. And after 10 years, based on that some scientists information, they may change the direction by putting some extra things. That depends. Now I am asking cloud cover, how it affects the ozone formation in the atmosphere. Okay. No presence of pollutant. Yes. What is that pollution? Presence of pollutant. Cloud coverage. Okay. The cloud coverage must be stagnant. Then only this reaction will take place, I said. If it is not, that point is important. You have to catch hold of that point. But that only repeatedly I was telling you. This stagnant mass, or stable mass, that is very important. If it is not stagnant, then this reaction will not be taken place. That not at all take place. That reaction is supposed to be taken, which forms the smoke and other photochemical component, means it must be that they may ask you in the exams, what is the essential parameter to carry out this photochemical smoke? That time you should not select some other answer. This could be the answer. Okay, then what is the characteristic symptoms of this smog products? For example, I told you ozone is a brownish gas. That is one of the important compound, and also which is reduce the visibility, eye irritation, respiratory distress, and plant damage. All these things damaged by the presence of ozone. The control of photochemical smog may require substantial vehicle reduction, which reflects concentration of NOx in the atmosphere. And especially this action is supposed to be taken in urban area, or we can say all main cities. At the same time, it is also necessary to control the release of hydrocarbon from where it is formed, where it is stored, where it is transported, and where it is distributed and stored. Everywhere the release of hydrocarbon will be there in the form of vapor, and whatever it may be, the engine is found in India, throughout the world, not only in India. Everywhere, whatever the engine they are using, during the burning of fuel at a time, because what is happening in a vehicle, only few fuel drops will go, the ignition is taking place. After ignite, there is a flow of fuel into that particular section. That's what your vehicle is keep on increasing. Automatically, it is happening. So we cannot stop it. And there, even then, the starting, when you are igniting, that time, since it is a volatile compound, it is evaporated and it is entered into the atmosphere. Around, it might be there somewhere I read in your book or somewhere I read, around 600 to 700 different components of hydrocarbons are there in the atmosphere. That is in the form of aldehyde, ketone, peroxides, organic peroxides, peroxyacetyl nitrate, many compounds. All these compounds are highly poisonous compounds which affect the entire ecosystem without could be recovered like that. That is the problem of that secondary pollutant, that is in the form of photochemical smog. Okay. And how this photochemical smog is formed from the photochemical reaction, we'll see. Any combustion of fossil fuel takes place when the temperature is goes up more than 600 or 700 degrees. There is a release of oxides of nitrogen, I said. That is in the form of NO or NO2 or NO3. All these, any one of the three form of these three gases. When the process of combustion, what is will happen? When the fuel is combined with the oxygen, which produces different combination of flue gases along with the carbon dioxide and a huge amount of heat energy. So this here the major component for forming smog is NO and NO2. So the initial combustion reaction when it takes place, N2 plus O2 or half O2, which gives 2NO. Okay, when this reaction is happening, it is very casual reaction, everywhere it happens. Not only the specific condition, specific things are required to carry out this reaction. It is commonly taken place everywhere. And for what will happen? Once this NO is released, that is not the stable compound. And when oxygen is there in the atmosphere, it is being converted into NO2. The NO2 is one of the major compound which involves in many reactions, even that with the water molecule or moisture in the atmosphere. when the condensation it takes place, which rain outs in the form of acid rain that contains nitric acid HNO3, similar to SO2. SO2 is there in the atmosphere, which reacts with or combined with the water molecule or moisture in the atmosphere. Then it combination of these two makes sulfuric acid component. When the condensation is occurs, that forms sulfuric acid, and acid rain will come that contains sulfuric acid. And some of these acids are in dry form also. That is very problematic. If it is in liquid form, from the smell at least we can understand this is the sulfuric acid. But when it is in dry form, we cannot make out that there is a formation of sulfuric acid. That sulfuric acid will be deposited any living or non-living things in the atmosphere. Once the rain comes, that is washed out from where it is deposited, wherever it is deposited, from there it is released. This is the common. But in this particular case, the NO is converted into NO2 with atmospheric oxygen. In case very bright sunlight is available, it releases the high energy photons. The photon will be absorbed by this NO2 in the atmosphere, and which can photonize, the sunlight can photonize the NO2. When it is photolizes, what will happen? The NO2 is absorb the solar radiation in the wavelength of 420 nanometer. Then it is being reduced to NO and atomic oxygen. This is very dangerous reaction in the atmosphere because of NO2 or NOx releases. Now NO plus atomic form of oxygen will be available in the atmosphere. Anyhow, O is not a stable compound. Oxygen atom is not a stable compound. Either it reacts with another atomic oxygen, it may form O2. But availability of O in the atmosphere is less. It is available in the form of O2 only in the atmosphere, not O. But the atomic form, which comes after photolized reaction from NO2, and again it reacts with atmospheric oxygen molecule O2, O plus O2, then it absorbs M. M means which is nothing but the molecules which are all present in the atmosphere. What are the molecules are there in the atmosphere? Abundantly oxygen and nitrogen only. Oxygen is 29 and 78% of nitrogen. Those gas volume. Why that gas volume is very important? Because the NO which absorb the photon at 420 nanometer only, it is being converted into atomic oxygen under NO. So how much energy it could be? That energy will be distributed to this atmospheric gas molecules, that is in the form of oxygen and nitrogen. In such a condition, this O3 is formed very happily. And this O3 comes out of this M also. The M is already existing in the atmosphere, but which is at very high temperature. Here, the ozone would have too much energy to be stable. If the energy is coming down means, again this O and O2 will be dissociated. So the heat energy is important for stable of this O3. Otherwise, it dissociate back means again oxygen molecule and oxygen atom will come. These two are also highly O2 is stable compound. O is also dangerous compound. If any water molecule will be dissociating in the atmosphere, if there is a formation of H plus OH minus ions are there in the atmosphere, then it makes OH minus. OH minus. Then OH hydroxyl ions are very good free radicals to initiate or to proceed many sort of photochemical reaction in the atmosphere. So in such a situation, we have to maintain the ozone molecule in the atmosphere at very high energy. Otherwise, it will be dissociated. This is the reaction, and this reaction is very fast or rapid reaction. And the ozone concentration will be low until NO value decreases to a low value in the atmosphere. What is the reason behind? Whenever that NO2 is converted into NO and O, if NO is accumulating more means, what will happen? The NO2 is coming, that is initial stage of reaction. The problem with such a type of reaction, these are all not irreversible reaction, or all are one direction reaction. If it is irreversible reaction means, then again the whatever the NO2 is coming out, that could be converted into NO2, then NO2 which absorb the sun photons, then it could be converted, all the sequence reaction that could be carried out. But here, the ozone concentration, the reaction is very fast reaction. The concentration of O3 will be less when until the NO value decreases to a low value in the atmosphere. Otherwise, the O, whatever released from that, that will be less energy, that will be dissociated. Then the dissociated thing is O3 is being dissociated into O2 and O. That could be the major reaction for this. And this is the set of transition. It's a cycle. How this cycle of this reaction is taking place in the atmosphere, we'll see now. Any sunlight, you can look at the book at the page number of 38. I could not load the diagram. Or you people, any one of you can take photograph and circulate is also okay and share through WhatsApp or through this online classes. What will happen? You look at the diagram. You look at the diagram in your book. What happened there? The solar radiation or sunlight fall on the NO2, which is on the atmosphere, which is released from the combustion of any fossil fuels. When it absorbs it, it is being converted into NO and O. The O is reacting with O2, which are present in the atmosphere, which forms O3. That O3 released into the atmosphere. Again, whatever NO is coming out by the photolysed reaction, that is being converted into O2 and also NO2. This NO2 is again entered into the atmosphere. And whatever the ozone is formed, that ozone is combined with NO, then that is released NO2 and O2. So this is the sequence of reaction is going on. By look itself, we can understand the diagram which is showing on the figure, which is taken place at the steady state condition. There is no accumulation of any product in any of the circle. From one form to another form, it is converting. Another form to another form, it is converting. At last, it releases NO2. That NO2 is released into the atmosphere. That again, the sequence of reaction is going on, keep on going on. When the reaction is happening under steady state condition, then we can understand that the whatever the production and destruction of the product involved in this reaction is at constant rate. And these products are very important product in the smog, NO, NO2, O3, and whatever they are formed in this reaction, and whatever it is destructed in this reaction, the concentration of all the components are same or at a constant. That's what the figure is indicating. Nowhere any accumulation of anything. NO is converted to NOO. And O is combined with O2, O3. O3 again is combined with NO, it is being converted into O2, NO2. And O2 and NO2 is accumulated in the atmosphere. So it is balanced. So there is no formation of extra component. So we can say that according to this diagram, whatever the diagram is being there, due to the rapid rate reaction of NO concentration will not rise after amongst in that what either it is being afternoon or morning or evening, whatever it may be, it is in the stable condition only. But that is not the case. We know that the ozone formation is not, ozone accumulation in the atmosphere is not constant. It is keep on increasing by release of many pollutant into the atmosphere, including say chlorofluorocarbon. That is the prediction or research reports are showing. If the reaction is happening in such a stable condition, then how we can say about that accumulation of O1 in the atmosphere? That is not at all possible, isn't it? But it has happened. The culprit for deviation of equilibrium of whatever the figure is showing in your book, that is happened by the release of hydrocarbon. The hydrocarbon which when they entered into the atmosphere, they induced to carry out some of the photochemical reaction in the presence of sunlight. Those reactions released many free radicals in the atmosphere. The important free radicals are, many are there, but the important are OH minus, and they undergo and releases many sort of product like oxides of nitrogen and aldehydes, ketone, and peroxynitrile. Many things are forming by absorbing that radiation along with that hydroxyl radicals. Then it undergoes the photochemical reaction which forms the ozone. Then ozone is built up in the atmosphere. So what are the main reaction of that ozone formation from the hydrocarbon? Everyone knows that there is a release of unsaturated hydrocarbon into the atmosphere and which promote the photochemical reaction in the atmosphere that form along with the presence of nitrogen oxide and the sunlight and a stable condition or a stable meteorological condition. They are forming or releasing many different products like aldehyde. We'll see what are they. RH means it is hydrocarbon. When react with oxygen, atomic oxygen, which gives that hydrocarbon which is highly active plus other component. Re means it is highly active component. And this time it releases lot of ozone also. That ozone is again react with hydrocarbon in the atmosphere, which makes aldehyde and ketones and ester components also. And those components are highly active. That means highly unsaturated compound. Then again, this unsaturated compound react with that hydrocarbon in the atmosphere, which releases some of the water molecule with again many-fold highly reactive unsaturated carbon into the atmosphere. This is the fact. Actually, this is the long chain reaction and long and complicated because the reaction is involved between the or with the free radical which generate one product and then turn it to form the second one turn and form the third one. Like that kind of reaction is keep on going on. When it is going like this, and there will be many starting and end point, and finally which is rejuvenate with that OH, that means hydroxyl highly active component, which readily pass from the chain reaction. And the amount of OH releases, the type of reaction taking place in the atmosphere, which is widely varied of hydrocarbon released into the atmosphere, because we can't say what will form at what time it will form. We are all saying all this. These are all the possible compounds can be formed from the through the photochemical reaction from the hydrocarbon combined with other things. The very commonly aldehydes and ketone also produce free radicals. When the strong sunlight is presented, then the aldehyde ketone ester products of hydrocarbons are formed. They are also radicals. And while ozone itself may attack unsaturated hydrocarbon to produce the similar free radicals, including reactive aldehydes. Aldehydes are very reactive. There will be only one oxygen. And these hydrocarbons are highly reactive hydrocarbons are reacted with oxygen, which gives the ketones, aldehydes. And whenever this esteric common or ketones react with that NO, which is released from the combustion of fossil fuel, which is being converted into NO2 and other aldehydes in the atmosphere. ROE means aldehyde. This reaction shows how the hydrocarbons help in the conversion of NO to NO2 and the breakup of oxygen, how it is happening. Breakup of ozone, not oxygen, how it is happening. So from that we can understand the ozone buildup in the atmosphere is possible when there is only one reaction is taking place in the atmosphere for the formation of ozone. That one reason is when atomic oxygen combined with molecular oxygen, that means O react with O2, O plus O2, that gives O3. That is only one reaction. There is no multiple reaction for formation of this. And it does not consume again. And once it is formed, it won't consume or touches or react with NO2 after reacting with NO. That is the major drawback. That's what once it formed, remaining thing will be accumulated. The sequence of reaction, whatever mentioned, it is a chain reaction. the product of one reaction is consumed in the next reaction. The next reaction product is consumed in the reacted for the next reaction. So we have find out there is a large number of free radicals in the atmosphere and which keep on released, and that they are forming different sort of product and keep on that reaction is going in the atmosphere. So it is accumulated in the air. When the bright sunlight is coming, whatever the product I told you, aldehyde ketones, along with the ozone and the pan, it is growing up like anything. And you can see the diagram which is on the page number, I don't know, 38 or 39. Whatever the NO2, it is formed or released into the atmosphere from the combustion of fossil fuel. Again, I'm saying, even plant release also is there. The plant releases and by the need nitrification process, that is not very high temperature. That is by the microbial activity, it is released, but that is not hot or it is not warm. It is in cold condition. That product may not be involved in this photochemical reaction. The products are released from the combustion of fossil fuel, especially from the vehicles. They are very high temperature. And that will be combined with the hydrocarbon in the presence of bright sunlight only. This reaction will be undergoing. So don't confuse that and that also NO2, this also NO2. Both are NO2, everybody knows, but the temperature at which it releases is different. So you look at the diagram, NO2 plus sunlight is there, which is converted into, fertilize the product in NO2 into NO plus oxygen. The oxygen is combined with the oxygen molecule, that is bottom of the figure. O3 is released. The O3, then it is released into the atmosphere, it is accumulated in the atmosphere. Similarly, the NO compound, when you are adding with the NO, from the atmosphere it releases, from the atmospheric oxygen react and it makes a highly reactive hydrocarbon. When it reacts with the oxygen molecule in the atmosphere, that forms our ketones, ester compounds. Then that compound react with that NO, which is from the NO2, and which releases NO2 plus hydrocarbon in the atmosphere. So, which forms makes NO2 from the release from the combustion, which makes our ozone molecule along with the NO2. So, here, what is the extra product accumulated? You have started from the NO2. You previous years released it. You start the reaction from the NO2. The NO2 react with the sunlight, it gives NO plus O. The O is react with O2, it gives ozone. And the NO react with the environmental component, that is hydrocarbons. That hydrocarbon is converted into highly active free radicals. That free radicals, when react with the atmospheric oxygen, is being converted into oxidative free radicals like ketones, ester component. That highly active free radicals react with NO. Then it releases NO2 and ozone. So it starts from NO2, it releases NO2 into the atmosphere, but which creates one extra component, that O3, that is simply released into the atmosphere. That's what that is called accumulation of hydrocarbon or ozone. Again, I'll tell you, you look at the diagram which is on the 39 page number. If the process starts at NO2, it end up with NO2 plus O3. So there is no precursor for O3. It is formed by the destruction and production of NO2. When it destructed, it releases O. When it is produced, it is formed O3. So there is no change or concentration of NO2 in that entire process. But when it underwent for the conversion process, it releases extra product as O3 in the atmosphere. So this cycle is going on one direction. There will not be any alteration in the concentration of NO2. But it along with that, and one more component is accumulated in the atmosphere is ozone. Like such a way only this ozone is formed, ozone is built up, and which gives all sort of dangerous effect to all the living things, because it affects human being also, it affects plants also, it affects the non-living abiotic things also, like building, car, all those things affected by this. Because the nature of ozone is highly oxidative chemical. Because of that oxidative nature only, this could be used as a water treatment byproduct. But that it is not 100% effective. To some extent it is effective, but even then it is very difficult to commercialize in one particular reason, because that area continuously exposure to ozone means all sort of disorders will come for the kids. To avoid that only, they are doing like all sort of things. Okay, this is about the photochemical reaction. Hydrocarbon smog means like what I have explained about the hydrocarbon in the from the first lesson, second lesson, and till now, that only the things repeatedly is available, nothing else is there. Affect the effect of or problem or impact of this photochemical smog on living things, non-living things, everything here and there I have discussed. I hope there will not be any new information for you in that. One or another way, I would have told you people. If I would have not been told directly, means indirectly, I would have told here and there. So the remaining part and the effect of air pollution, lesson 4, that also I would have explained here and there. Nothing new will be there. If you read, you go through, you people go through. If you find out something new, means let me know. I will discuss. Now in the afternoon, now already time is up. 1:14, 1:15. It will be stopped. In the afternoon class, directly we'll go to the air pollution laws and standard. From the air pollution laws and standard, you may expect two questions. One, two, both are maybe the small question. Whatever the completed lesson, from that they may ask what is photochemical smog. Sometimes they will ask how the ozone is formed. Sometimes they will ask about what is the rhythm of ozone in the atmosphere. So whatever I have explained, how it is formed, everything you have to write. Okay. So three possible questions from that. From the lesson 5, again I am telling you there must be two questions. One is what is meant by air pollution index, and sometimes they will ask you what are the different amendment or policies of air pollution, the prevention and control. The pollution abatement for prevention and control. For that, what are the amendments are they will like. And we will see how these Indian cities are affected by this air quality, how this air quality could be assessed. That is very important. NAAQ means National Ambient Air Quality Standards are available. Make use of that only. The entire world air pollutant concentration is being identified. That model proudly we can say Indian only adopted or developed. Indian developed that model is worldwide agreed and accepted. Throughout the world, they are following our protocol only for analyzing the air quality. So proudly about that, we will discuss in the next class. Okay. Now, ma'am, if you have any doubt, any confusion, you can ask. Or if you want to wind up also, you can wind up. We'll start by 3:15. Okay. Okay, ma'am, carry on then. We'll see at 3 o'clock. So when you want to, you come little earlier or you stay little later, we will discuss whatever you ask. Okay, ma'am, bye. Consequently, I can explain about the hydrocarbon, but not much. You people will read means you can understand it. Nothing new to say anything about that. Yes, yes, yes.